Welcome back. This is the first real video on trying to understand the property of aromaticity. Now, for this first problem, I am not looking into all three criteria to determine whether the molecule is aromatic or not. In fact, that's not the purpose of this question. As you can see, the question stated here is, does the molecules shown below obey Huckel's rule? So essentially, all I want you to do for this particular problem is whether or not this molecule obeys Huckel's rule. Because I think at some point, most of you could do the two criteria. It's always the third that seems to be the problem. Because you may have missed the nuances of certain things I mentioned in the introduction video. Maybe if you think, oh, where did he said that? You may have to go back and watch the video and understand all three criteria very clearly. Okay? Without further ado, let's go get started. All right? So what is this Huckel's rule? As I've mentioned, is 4n plus 2. Okay, 4n plus 2 pi electrons. Okay, electron is E minus. Okay, now let's take this molecule. This has got two pi bonds, right? So 1, 2, 1, 2. So it's got total of 4 pi electrons. Is there any way we can get 4 pi out of this? Well, you should be able to substitute values of n equals 0, 1, 2 into this so that you should be able to get 4 pi back. If you can't, that means you're probably not going to, that particular molecule doesn't obey Huckel's rule. So you may not even have to do the other two criteria sometimes, right? Just do the Huckel's rule first, and I think that automatically will help you determine if the molecule is aromatic or not. So if I put 0 in here, that's 4 times 0 plus 2. I get 2. If I put 1 here, I get 6. So between 0 and 1, you cannot put fractional values. So either of these conditions does not bring back 4 pi. So that means this molecule does not obey Huckel's rule, right? Let's take this one. Here we got 1, 2, 1, 2. We're only interested in the pi bonds, which is the double bond. It's just pi is alternate name for double bond. So we have a total of 8 pi electrons. So 4n plus 2 equals, we want to get 8 out of this, right? Don't worry about the pi. So if you put 0, so as I did earlier, so I'm going to get 2. If I put 1, I get 6. If I put 2, I get 10. So none of these values for n ever gave me 8 back. So again, this does not obey Huckel's rule. Now here is tricky. If you missed the key word, we only count the pi electrons inside the molecule, not what is attached to it. This is attached outside the ring. This is what really counts, right? So this may not end up meeting the requirement for resonance, okay? Like it may not meet the other two criteria. Again, we're only simply focusing on the Huckel's rule here. So here we have just 2. This doesn't count, right? So we have 2 pi electrons. So 4n plus 2 equals 2 pi is what we want to generate. If I put 4 equals n equals 0, we get 2 back. There we go. So this obeys Huckel's rule. Now again, same deal here. We got 2, 1, 2, 1, 2, 1, 2. So this is 6 pi. So we got 6 pi electrons. So 4n plus 2 equals 6 pi is what we want. So n equals 0, we know it's only going to give us 2. So 4n plus, if we put 1, then we get 6 back. So yes, this does obey Huckel's rule, right? So that means only these two molecules obey Huckel's rule. Now, why do I have to do this particular problem is because for some reason it's easier to do the other two criteria over this, which is even easier, but for some reason people find it much harder. Now again, the take-home messages is not so much applying the formula which anybody can do, but this is the key here. the double bond outside the ring does not count. It's only what's within the ring that counts, right? So this is how you solve a problem on Huckel's rule. So I'm going to actually go back and get rid of that square. So this is how you do just the Huckel's rule part, because other two cannot just be worked out, you know, like a problem. You just have to do a bunch of them. So that's why I decided I'll make a video separately on Huckel's rule, and I make a video now where we're going to put all three criteria into place. But again, like I said, mostly if you just do the Huckel's rule, you can just say whether the molecule is aromatic or not. All right, so stay tuned.